So a definition of a z-score is, suppose the data set has a mean of x bar and the standard deviation of s. This z-score for a member of x is the data set, is the deviation or the change from x to the x bar over s. What they are saying is that, say you have a bunch of data points. They want to know how far away from the mean you are. Okay? It's the distance from the mean divided by the standard deviation.
So like a singular deviation divided by like the...
Wait, the distance from what to the mean?
Okay? So say you have
Wait, the distance from what to the mean?
the distance from a point. So some piece of data to the mean. Okay? So for instance, like this problem right here. Nancy scored 87 on her math quiz and the mean was 70. Okay? And the standard deviation was 8. Find her z-score and tell her how far her score was from the mean.
Will they always tell us the deviation, or do we have to find
Yeah, they tell you the deviation. So on this one, we're doing 87 minus 70 over 8. Okay? So when you do that, you have 17 over 8, which is the same thing of saying just about a 2.1. So that's the z-score. Okay? The next example is this. Ned scored 5.8 on a pop quiz, and the mean score was 6.4. What? The standard deviation was 0.9.
So you take 5.8 minus 6.4 divided by 0.9.
Yep. So
You
5.
always take the first one.
Well, you take the actual data point minus the mean.
Okay, wait. Is that 2.1 equals z-score?
Yep. So when you do this, you're going to have a negative number, and it's going to be negative 0.7.
Yeah, I got 0.6.
Okay, if you round it up.
Oh, okay.
Yep. 0.666 is the same as
Is it
0.7.
okay that it's negative?
Yep, it can be negative.
So that's the
Okay.
z-score then?
That's the z-score for this one. Yeah.
So on every problem, should we give us a step?
Yep, pretty much. So I want to explain to you guys what a z-score exactly is now, which is why I gave you that handwritten piece of paper. So can you guys take that out? Because this doesn't tell you anything about what a z-score is. Yes, that one. Okay.
Okay, because
There's some more over there. Okay. All right. So here's what it is telling you. Here's your mean. Here's a -1 standard deviation, a -2 standard deviation, -3 standard deviation. This is 1 standard deviation, 2 standard deviation. I'm trying to make sigmas. I don't do a very good job drawing them, but you guys get the picture. Okay? Remember those sigmas, baby sigmas? Okay, so here we are, and you're going to end up with what is called a normal curve. If I draw it very nicely, and I didn't there, obviously. If I try it again. There we go, that looks a lot better. Okay? So, the normal curve tells us the amount of population that landed in this. Okay? So, I want you to make a vertical line next to it for an axis and put on it amount of population. When you have a teacher that says they're going to grade to the curve, guess what curve they're talking about?
That one.
This one. Okay?
Which one? The bad one?
No, this one. This is called a normal curve. Okay? In anything in population, if you're checking averages of height or averages of speed, most things are in a normal curve if you were to measure it out. Okay? Now, one thing I have to tell you is that what we just measured was how far or how many standard deviations are we away from the mean. Excuse me. So, back to the other one, it said Nancy scored 87 on the math quiz and the mean was 70. So, if I were to look at this as the math quiz and her mean was 70, she scored a 2.1 deviation, so somewhere in here was where she scored a 87. That was her actual score.
What does that say on the back?
Amount of population. So as you can see, her distance from 70 was a 2.1, right?
Wait, ours says 68.
Yeah, it's-
Or are you just using this example, this one?
Are you talking about, are you referencing 1A?
I'm referencing 1A,
Okay.
where we earlier found that Nancy went from 87, she had a score of 87 and the mean was 70. She was 17 away from it, but then if you divide it by 8, she was a distance of 2.1 from the mean. No. So basically, what it's telling you, the z-score is 2.1 standard deviations away from the mean. Okay? That is what a z-score is.
Was that the 68% that we have on?
Okay, so then, yes.
Wait, so if you were going to find like the actual number, this way would be 2.1.
Yes. Okay? Your z-score is the amount of standard deviation from the mean. Now, the nice thing about this is it kind of gives you an idea of where you are compared to the rest of the population. Okay? So, I'm going to try to scroll down. Oh, I didn't want it to do that. Hold on. Hold on. Chill. Okay, that's why I did it. Okay. So, what I have on your paper is that anyone that is from between the negative z-score of 1 and a positive z-score of 1 is 68% of the population lies between these two lines. Okay? It's already on your sheet. Anybody that is in between a standard deviation of -2 and a +2, 95% of the population is in between these two lines. And then the larger one, going from 3 to 3, 99.7% of the population is in between these two lines.
Is not or is?
That same percentage should be like on the negative end or on the positive?
Yes. So what I have left over is 0.3%, right?
You said is or is not?
99.7% of the population is between -3 sigma and 3 sigma. Okay? If you happen to score something over here, you are actually like in, well, kind of an outlier. Yeah, you're one of the, there's only 0.3 of the 0.3% left for both sides.
So should all these be 0.3, 0.2?
Nope. Nuh-uh.
Is that a 0 or
So-
a sigma?
Sigma.
Oh, okay.
Okay, so this is actually 0.15 of the population down here that's left over. This is 0.15 of the population down here that's left over.
So is it -20 sigma?
Nope, it's just it's -2 sigma.
Oh, it's a sigma.
Those are sigmas.
Oh, I
Yeah,
thought it was
sorry, I don't draw very good sigmas. All right, so anyway, that means only 0.15 of the population is sitting above this line. So that means you are very unique if you get a score above the 3 sigma. you are in bad shape if you get below the 3 sigma.
Wait, okay, so what does the sigma stand for?
Oh, this is above.
Yeah, so if you get above, this is like incredibly awesome, you're a genius. If you get below, you got some catching up to do.
Wait, what is the sigma?
Okay, so let's look at this theorem, the mean and standard deviation of z-scores. If the data set has a mean of x bar and a standard deviation of s, the mean of its z-scores will be 0. Remember, if we make that curve, the mean is right in the middle, right? Okay, so that means the z-score right at this point is 0 is what they're saying. Okay, because it's no standard deviations away from the mean. Okay, so now Mark has scored a 78 on a history test on which the mean was 71 and the standard deviation was 10. So that's one part we're looking at right here, the yellow. Okay, the next part we're looking at is he scored a 68 on a chemistry test. The mean was 62 and the standard deviation was 6. The question is, use z-scores to determine which test he did better on. So we need to find the z-score on the first test.
You want like a higher 7. The highest one possible.
Yeah, you want the highest positive one possible. Okay, so this would be 78 minus 71 over 10, which is 0.7. Okay, that was his history test. Do the same thing for the chemistry test now. It'll be 68 minus 62 over 6. Okay, that would be 6 over 6, or that would be 1. So which one did he do better on? Chemistry. He is 1 standard deviation away from the mean.
So it's better to be closer to the mean?
No. On a test, you want to be the most positive
right?
possible. More to the right as possible, yeah. Okay?
So he did.
Mark, on this case, the first one, here's your first standard deviation right here. And here's your second one here, right? So, that's supposed to be a sigma. So, in other words, Mark, on the first one, scored somewhere right in here. And on the second one, he scored right on the first sigma. So he did better on it.
Found it.